Hello everyone, in this video I wanted to show you these undervolting settings for a system running Ryzen 7 9800X3D, 64 gigs of 6200 megatransfers memory. So it's been running only 7 hours of VT3, but I really need to get the system to the client. So I will now run the other tests and show you the results. So let's start with ADA64, and in the meanwhile we'll look at the settings on the right. You can see that I set the ratio for MCLK and UCLK to 1 to 1, and the FCLK is in like 2 to 3 mode, so it's a little bit synchronized, and that should give you a latency advantage. And you can see the latency is 7 to 9 seconds, and we're running a CL34, and then 39, 39, 38, 96, TFC 68. Everything here is close to being bottomed out. TFC, I could go lower and get a little bit lower latency, but I would lose on impact scores, so I consider that not to be stable. But it's a very, very good result, and so that means that this memory is ADI from Hynix for sure. And as you can see, the voltages are very low for the memory, and that means that I can run without a fan on the memory. That is very convenient. And that's 128 on the memory BDD, and 122 on the VDDQ. VDDIO for the memory for the CPU is 107, and VSoC is 136. I don't know. I mean, people usually run those systems at single rank configuration, 32 gigabytes, and this is a dual rank, so that might be the explanation why the SoC has to be that high. That's probably the reason. So yeah, I only have the free version for ADA64, but yeah, 72 nanoseconds. Let's now run Limpak. In the meanwhile, here's the system running, and I have a fan on this direction to help the VRM cooling, because this is a very low-end motherboard, b650m D3HP-AX. This is 120 euros motherboard with Wi-Fi, and that's the cheapest, like, doable motherboard with some heatsink on it, but it was still getting super hot on the VRM, and that didn't really affect the scores for any benchmark. Like even Limpak, after a lot of runs, after 12 runs, wouldn't show any regression, but I decided to put a fan on that area anyway. And then I put a lot of heat sinks spreaders on the back of the board to improve thermal transfer. The machine will be used for gaming, and that means that the CPU will never run at full speed, full throttle all the time, but just in case, they're cheap. Memory was extremely cheap for the quality. Is that CL30 135 volt, which is very, very good bin for 32 gigabyte sticks, and that shows really with the settings that I was able to achieve. And now, of course, I'm running with the iGPU to test the system and not to waste more heat and energy in the system, but I will put the GPU inside and then provide some cooling on the memory afterwards to avoid the GPU cooking the memory. But at the default 135 volt setting, memtest 5 TM5 would crash, would show errors in the end. And well, this configuration doesn't have any problem running TM5 with 128 volt and CL34. That of course is a trade-off. Not running CL30, that wouldn't be stable with this voltage, but I'd rather have the memory last longer and the system be more stable. And also note that because of how this system is built, how this case works, I am not able to put the second fan on the 2040, only one, so that stays like that. We'll of course move this and yeah, be able to close it on the top. I already did that for other systems, and this is a very cost-effective case from iTech. It's called the Evoke Pro, and yeah, I have a lot of those. And yeah, they're very, very nice case for the average user. Very compact and provide full length for the GPU. I drill on the front to be able to place a 120mm fan here with the GPU inside to provide better cooling. And of course I will put a lot of fans on exhaust here and then another small one here as space allows, and then another small fan on the memory sticks again. Well, now let's see how Limpak does. So here's Limpak running. Gonna finish 7 loops now, and there we go. So let's now run hardware info while we do a little bit of Y cruncher and take a look at the temps, voltages. So nice 105, and let's get down here. So we're not throttling, we're 82 degrees, 120 watts. So that's under 120 watts. Here's the score. Let's now run pi prime. We'll keep a look on the secondary voltages. So SoC voltage is reported here. Oh, it's moving between 128 and 1.3. Interesting. Yeah. So the total system power is a little bit over 121. Not much more to see there. Some voltages are not reported, and I have a bug where if I set them in the BIOS, the system doesn't boot, whatever voltage I set there. And these are the VDDG, those two. Yeah, there's a menu for them in the BIOS, but whenever I put them, the system wouldn't boot. I don't know if it's a BIOS issue for this 9000 series. It's a Gigabyte issue. I really don't know. Skill issue. Maybe I should look into another submenu to set them. Could be, because if you don't know, in the every motherboard BIOS on AMD, you have the motherboard vendor BIOS setup, where you can set voltages and stuff, and then you have the AGISA, so the official AMD menus. But yeah, let's see. Oh, and while we're at it, I'll give you some hints. So the SoC was the hardest to stabilize because it will crash after hours of stress testing, like 8 hours on the VT3. I will get one error at 1.20.255, so I had to put 1.26, and that lasted me for the hours you see before, and I think even more. And then TRP38 was also I tried to set it 737, and it took a little bit to figure out that was causing issues, but I don't remember which test would actually reveal that, but probably VT3 error again. Yeah, these are basically set by Buildzoid guide, and they worked, so I didn't bother moving around with those values. Yeah, the memory voltages again, if I lower them, I get slight regressions in the scores of the test before getting real errors, so I didn't even try to test them for a long run. For example, if I put 27 on the VDD, yeah, every score basically drops a little bit. It's consistent, it's over margin of error, and so therefore I didn't even bother testing for hours, because that's whenever you get a drop in performance, that's a sign of instability. And also the scores were basically the same at 135, of course, and at 35 I could run CL30, but 35 voltage CL30 without fan will crash in the long run, even TM5. So let's get to the BIOS, see the settings there, and then we're done. So here it is. There's nothing set there, I think. So this is what do bug out if I try to manually set them. The VDDP does work. So memory settings. Here we are. I didn't end up tuning these, so these are not minimized. Sorry, lack of time. So yeah, RTP was also like changing nothing between 20 and 22 really, but 20 worked fine, so I kept it. And I think I've talked about everything else in the... Oh, also, if I run the ddr5 higher, I don't get any performance benefit, so I don't do it. 65,000, like the maximum ddr5, which is... What is that? This one. Didn't give me any performance benefit, so I didn't bother testing it. No test showed any improvement. And then there's, of course, the curve offset. Here, curve optimizer, and that was stable, and 24 was not. So I kept it at 22. I probably shipped the machine at maybe 20, I guess, just to be sure. And yeah, I think that is really all for the video. And thanks for watching. Ciao tutti.